Hi, I'm Meeeke. Today we are tackling professional platformer physics in Scratch. The platformer like this. We'll build two versions. The beginner version uses standard blocks to get you started fast. The advanced version uses hitboxes and state machines so it feels like a real professional game. I'll break down the why and how behind the code. I'll hand it over to my digital assistant to guide the build. Let's get started.
I'm the digital assistant. Let's look at the beginner version. This build uses a single screen architecture with basic gravity. To set it up, we have three main sprites: our player cat, a ground platform, and a collectible apple. I wanted to use coins, but since there's no default coin sprite in Scratch, I compromised with apples. The movement here is straightforward. We use a variable called y-velocity to simulate gravity. Every frame, the character falls, and if it touches the ground, it simply moves back to its previous position. I assign the right arrow key to move right and the left arrow key to move left. It's the perfect starting point for any new coder. To tell the cat, this is the ground you walk on, we add a simple ground line. This gives our character a solid floor to interact with. The apples are created and placed at the very beginning of the game. Using clones like this saves a lot of time compared to placing each one manually. For our objective, we use a simple collision check. When the player touches an apple, we increment the score and delete the clone. It's a quick way to add a core game loop to your project. Let's see how it works. Our beginner game is fully functional and great for learning the basics. However, the cat isn't very lively, there are no enemies, no scene changes, and no goal. It's a bit boring. Let's add more and make it a real game. Let's upgrade to the professional version. We are moving to a multi-stage architecture using invisible hitboxes and state machines. For this version, we've upgraded to professional Kenny assets and implemented a 3-stage world transition. You'll notice these sprites look different from the defaults. These are from Kenny.nl. He offers an incredible amount of his work for free under the CC0 license. Huge thanks to him for his contribution to the community. As a pro, I don't recommend using copyrighted assets from the internet. CC0 assets like these are the safe, professional way to go. Here is the core part of the character's movement. We use apply_physics to handle all our gravity and collisions in one clean block. Update_animation to change costumes according to the player status, and check_death_zone to handle what happens when the player falls off the screen. The biggest secret to smooth movement is the hitbox. Instead of using the character's image for collision, we use a perfect invisible rectangle. By treating the player as a simple box during the math phase, we ensure they move consistently regardless of the current animation frame. Just look at the difference here in our testing lab. The player on the left jitters because its limbs touch the ground differently depending on its walking costume. But the player on the right uses a hitbox, making its movement buttery smooth. To make the character feel lively, we use 3 types of costumes: stand, walk, and jump. We decide which one to show using a variable called is_grounded. This tells the game exactly when the player is on the floor or in the air. But is_grounded is a little bit tricky. Let's take a look at how it works in the animation lab. It shows a super slow motion view of how the player lands. The player falls from mid-air and the state stays, not on the ground, until they actually hit. Once touched, the state changes to on the ground. However, the player actually sinks slightly into the floor before being pushed back. It repeatedly falls and moves back until it settles. This small correction causes the state to flicker and creates a costume problem just before landing. In the game code, we have a trick to solve this flickering problem. When the player is within 10 pixels of the ground, the state is forced to on the ground. Thanks to this sensor, we don't see any flickering while playing the game. We've implemented a multi-screen system. Instead of a complex scrolling camera, we detect when the player reaches the edge and instantly load the next stage using a broadcast. This allows for massive levels while keeping the code simple and lag-free. Finally, our animation state machine uses player input and grounding status to perfectly switch costumes. This gives the character a responsive, professional feel that reacts to every move you make. To make the game more challenging, we added slime enemies. Their logic is very lightweight. They move continuously in one direction until they bump into a wall or reach the edge of a platform, then they flip and walk the other way. If our player's hitbox touches them, it's game over. Adding basic patrol logic like this instantly turns a simple physics demo into a real game. Let's see how it works. We start in stage 1, which is designed to introduce the player to the controls. Notice how smoothly the character accelerates and comes to a stop. That's the physics logic at work. The floating platforms in the center are the first test of our jumping mechanics. Because we use a hitbox, the landing is perfectly precise every time, with no jittering or sinking into the ground. As we move into stage 2, the multi-screen system instantly swaps the terrain. Here, we face our first obstacles, the slime enemies. They pace back and forth using their patrol logic, flipping whenever they hit a wall or the edge of the stage. This stage tests our timing. Since the player hitbox is exactly the size of the character's body, you have to be careful not to clip into them, or it's an immediate reset. Finally, we reach stage 3, the ultimate test of our platformer. We have wide death pits here, so if you miss a jump, you fall off the screen and trigger the death zone logic. To reach the end, you have to navigate these higher floating platforms. It feels robust and professional, just like a real game. And there it is, the green flag. Once we touch it, the victory broadcast is sent, and we've officially beaten the game.
Thanks for watching. All the project files and assets we used are linked in the descriptions below. Please let me know in the comments what we should build next. Happy coding!